Okay. So we can start now. So welcome back to this afternoon session. Is the fourth session from this workshop and the last one. So what we're going to be discussing this afternoon is advanced materials, and it's really also trying to connect and exploiting the lessons learned from nanomaterials. To which extent we can try from those lessons learned, and to which extent there is something that we need to be doing differently. So we will have this afternoon, we will start with a presentation from Lars Montelius from the Advanced Materials 2030 initiative, who's graciously joined us because I think you are in another meeting at the same time. So thank you so much, Lars. And without further ado, perhaps I can just give you the floor so you can just start with the presentation, and we will be moving the slides for you.
Okay, thank you very much. Very nice to be here. Thanks for the invitation. And we can take the next slide directly just to give you the overview how I intend to speak about this. I will say some few words about the Army 2030 ambition and its vision, and then speak about, let's say, state of the play, where are we right now, and then the next steps. So rather simplistic, I think. So we can take the next slide. And this is the, I would say, the thought-provoking slide saying what are the issues actually. So everything is about an Advanced Materials 2030 initiative, which was built on the Materials Manifesto that was published last year in January. This year in January. So what are the issues? Well, the issues are manifold. First of all, materials. I think we kind of all agree that materials is an enabler for all kind of industries. It could be raw materials, it could be process materials, it could be production processes, production machines, manufacturing, and everything is based on materials. So materials is in a way the mother of innovation. And the issues with this is, of course, since it's so much large enabler, it goes into all different verticals, all different, call it business market, if you like, or innovation market. And here comes one of the problems. That is that if someone is doing, let's say, an innovation or a discovery in one of these silos, it will take time before it diffuses to the other silo. And they may even work on the same thing without communicating with each other. So there is a problem here that being so enabling, it goes into the different verticals, all the verticals, and then a lot of things are happening there. And then from societal point of view, we do not think about the materials per se, but we rather think about what is the impact, what is the output. It could be a new energy system, or it could be a new way to transport people, like what are doing now with electrification of cars and buses, etc. And then thinking about this with the cars and buses, I mean, they are becoming not just pure transportation vehicles, but rather a part of the digital society. They are computers on wheels, and they are connected with each other, taking up different kind of sensoric inputs from wherever they are in the local settings and aggregate that, of course. So that's good for the digitalization. So this is one issue happening right now, is the digitalization of society. And then the materials aspect, which is generic. And then thirdly, the, let's say, the Green Deal, or the necessity to stop to use the scarce resources on Earth and instead bring much more sustainable issues, much more cyclable, much more kind of more lean processing, using green electricity, etc., etc. So all these things are connected, the green and the digital transition, and then having the materials as the, let's say, the enabler or the mother of it all. And then how could we kind of think about this? And then if you think about all the different projects that is ongoing, we have all the KICs, all the knowledge innovation communities, for instance, one in raw materials, one in energy, one in other things like manufacturing, etc., etc. And all of these, they are, of course, their own ecosystems, and they do a lot of stuff inside each ecosystem, but there is no connectivity. So, and we're not taking advantage of the digitalization that would actually enable a connectivity, and that would enable a much more quicker path to innovation if everything were connected. And we're living in a time now where we have the digital tools that, based on different kind of principles like blockchain principles, etc., would allow to have a connectivity. Because in the end, you could say that, well, how to handle all these things would be to centralize. I mean, okay, we have like the European Commission, they should know everything, and then we centralize the power there. So all these different things happens, goes to the European Commission, they know about it, and they diffuse something they like, and that's it. But centralization is not what we need. We need a decentralization. We need a connectivity between what is happening in the companies with the people. We're having now the generation Zeta, who is not just taking a job because they would like to get some payments. They just take a job if it is meaningful for them, if it is meaningful for society. So we need a much more stronger connectivity between, let's say, the practitioners and the citizens. And we are all citizens. We're all kind of citizens, and we're using the things, but we don't want to buy things that are not sustainable. So having all these kind of things there, then we say, okay, what shall we do? And out of this, what shall we do, came the Materials Manifesto. So now I can take the next slide. And the Materials Manifesto as a vision, and I think it becomes clear now what the vision is: a strong European materials ecosystem to drive the green and digital transition alongside a sustainable, inclusive European society. A really inclusive European society. We can call it a commons, if you like, through systemic collaboration between upstream developers, downstream users, and citizens, and all stakeholders in between. So this is like a umbrella around everything, kind of, right? And then thinking, having this vision based on what I discussed in the previous slide, and then with the big challenges that are ahead, which is the climate neutrality by 2050, the necessity to reduce the environmental pollution, and the necessity to prevent the scarcity of resources. So we need to continue to live on Earth, right? So we are at the tipping points. All these big challenges are there, and they can be tunneled into this materials vision or the materials ecosystem, actually enabled to develop something that we do not have yet. So it's a mega big undertaking to speak about a system that will allow all these things to be connected. So we have all these dots, and there is no connection today. They're dissociated with each other. So it's building a system that will actually connect all these things, enabling that knowledge being generated in one part will effectively be distributed to become also an income knowledge into another kind of sector or vector or innovation market, whatever we like to call it. So if we take the next slide, the overarching goals, having said all these things, are three things. One is to safeguard Europe's technology leadership, and that will enable to have more jobs in Europe, safeguard jobs in Europe, right? And then secondly, to reduce the environmental footprint, that Europe should go in with the flag high and say, we are the guys that will reduce the environmental footprint in all kind of production, all kind of materials, all kind of sectors in society. And then thirdly, to secure the strategic autonomy of Europe by having production then in Europe. And everything is based on these three P's: the planet, the people, and prosperity. And of course, then taking into account the climate contribution, reducing the carbon dioxide, circularity of materials, and zero pollution and non-harmful pollution. And if you think about this and then think about standardizations and so, there is a big opportunity here, right? Because in order to actually drive this forward, we would need new kind of standards that will secure that a product that is being produced actually fulfills all these goals. So there is a new way to kind of bring standards or agreements or whatever we like to call it into play. And it's a necessity. And here is, of course, an enormous opportunity, I think. So if we take the next slide. The four main drivers, I think it's maybe kind of obvious. One is the, let's say, the cross-sectorial industrial innovation. Another is paving the way for the engagement of all stakeholders. And you can say all stakeholders within advanced materials, but in principle, that is all stakeholders, everyone. And then the third, fostering the collaboration based on common grounds between different stakeholders. And this is this commons idea, or the materials commons idea, that I briefly touched on before. So it's really about a kind of an agreement to make more sustainable products through material-based technology, and less pollution, circularity, etc. And then the fourth driver is the necessity to address all the value chains and innovation markets for planet, people, and prosperity to achieve that. And all the different innovation markets or value chains, if you like, is touchable because materials is an enabler. It's a generic kind of enabler that is needed everywhere. It has been so since the very beginning. We have the Stone Age, the Bronze Age, and everything is based on our capacity to tune materials into something that is useful. And that's how societies are built. So if we take the next slide. What we did in the Materials Manifesto was to identify 9 different innovation markets: healthcare, construction, new energies, transport, home and personal care, packaging, agriculture, textiles, electronics, and appliances. It is, of course, maybe possible to make even more innovation markets or fill up the picture even more, but I think these are the 9 maybe most important innovation markets, or markets, if you like. So every market has an innovation market, of course. So what we are concentrating our efforts now is to see what are the commonalities, what are the things that are kind of appearing in these 9 different innovation markets and have some commonality. If the same thing appears in 3 of these innovation markets, or maybe in all 9 innovation markets, it has a very strong commonality. If it is only one, it's very much more silo-oriented. So what we are trying to identify now is to see what are the things that are more happening in the different innovation markets, and then we put efforts into that to see how can we enforce, how can we help, how can we guide. So we create this European ecosystem of materials. So if we take the next slide. So I think this kind of summarize where we are in a way. So we have 3 parts, in the gray parts in the middle, the digitalization of materials, and here comes all the materials, or rather all the knowledge about materials is now in the pathway to become a digital data point or digital data points, which means that we can put everything in a kind of a database. And I'm not speaking about making a new database. It's about really a Google kind of database where all the different databases already existing can start to talk with each other in order to be able to have a very quick diffusion between databases about the knowledge that we have, all the publications, etc. So it's really about taking care about the materials digitalization, and then also use in the research in itself also the possibility to actually take much more advantage of what is already known when we develop new things. So it's really about integrating the things. And then the material scaling up in the middle, and the materials priority areas on the right side. And then on top of this, we need this kind of new form of cooperation, a new form of commons, if you like, an inclusive governance. And we are working quite a lot about that right now, because we need something new. We do have the tools out there, right? So we can use blockchain in different ways. We can take smart contracts, also you know what that is. So there are things out there that has not yet been used, right? And then in the bottom, we have the connecting the blue sky research with the market demands. So it's really all the technology readiness levels are represented. And then in the end, we also need these kind of using this knowledge to make policy recommendations to other politicians that are evidence-based and not just based on what people believe or think, but rather based on evidence, based on science, based on research and knowledge. So next slide. Where we are right now, we are kind of in the, well, here in October, November kind of area. So we are looking now on the different innovation markets quite heavily, and we are building a strategic research agenda that is with an estimated time to be delivered, principally ready by the end of this year, but delivered to the EU as an important stakeholder by beginning of February next year. So this is where we are, and what we believe about this is that this strategic research agenda will show a lot of different things that one need to do, but also how can we actually make this happen, and what are the instruments that could actually foster this. And this includes the funding instruments. So probably some kind of private-public partnerships, probably between the member states, different entities like big companies, as well as the European Union, and most importantly, us as citizens. We need to be part of this. So it's really something very novel that we're trying to make here. So if you take the next slide. This comes about, we have right now an interim governance. So we are the interim governance working now since, let's say, since June, when this was presented in the Industrial Technology Conference in Grenoble. So we have a steering board, we have a core team, and then we have engaged stakeholders that are working in different working groups. So we have 5 different working groups, one about materials digitalization, one about materials scaling up, one about materials policy support, one about materials priority areas, that's the innovation markets, and the 5th one is about the instrument selection and implementation. These are the different instruments, the public-private partnerships, etc. There is a core team, which are the guys who actually do a lot of work here, and then there is a steering board with a lot of different people connected that were part of building both the manifesto as well as the draft roadmap for the Advanced Materials Initiative 2030. And then, of course, we would like to have more people getting involved, particularly in the 3rd part, in the engaged active stakeholders. So if we take the next slide. We can skip this because I think orders, and we can take the next again. So anyone can join, any European organization can join. So you can just go to the web page, AMI2030.eu. You will see if your organization is already registered or not. If it is not, you can register your organization. And then you will be kind of allocated, or you will be asked whether you would like to contribute to which working group, and then you will be part of building this strategic research agenda from now on until end of this year, and probably sometime in January as well. So if you have not yet joined, please try to join. I mean, the space is there, and we would like to have more people to join. And right now, as was mentioned before, we have a conference in Belgium, in Mons, where we have a lot of more participants being engaged there. So please join us. And I think this was my last slide. So I think next slide is just bye-bye slide. Yes, okay. So I'm ready for questions, or if anyone would like to ask something or give a comment or so.
Thank you so much, Lars. So we will have some time for discussion at the end of the full presentation, but I do want to open the opportunity if anyone has like a question of clarification to Lars, if you wish to raise your hand or just add it in the chat. Mm-hmm. Just give them a second.
Because unfortunately, I will not be able to be there in the end of this session. I need
You're
to
not
leave.
able. So perhaps I can ask you a couple of things, Lars, while people just gradually dare to take the floor. I was wondering. I mean, you mentioned that this is a European ecosystem, and when you mentioned about stakeholders joining, you also mentioned that it's European organizations. So to which extent international involvement is included or is welcome or is needed in this roadmap?
No, yeah, I think it's very much welcomed. I think what we're speaking about is something that is also generic in a way, right? So there are similar kind of thoughts in let's say in the United States as well as in Asia. So I think it is important that we're joining forces and not polarizing, right? But of course, this is based on a European initiative, but we need the interaction with other initiatives. And I think there will be 3, maybe 4 big initiatives about advanced materials, and they need to be connected with each other. Although the funding mechanisms will probably say that it will run on, let's say, on the European soil. But of course, when we speak about European companies, they are multinational, so they have operations all over the world. So we need to, again, reframe from this kind of old-fashioned systemic thinking that everything should be centralized, right? Much more decentralized, and it should be beneficial. If you are part of it, then you have some benefits. You also have some obligations, of course. So that's why we need this kind of governance for interactions and participation. But the idea is not to lock things, but rather to open things. So much more open innovation inspired, if you like. Right?
Okay. Thank you so much, Lars. I do have a questions on the chat. I don't know how do you pronounce Amiri? I do it in Spanish, but the advanced materials 2030 have a definition on advanced materials that they are using?
We do have a definition that I do not remember by heart right now, but it's principally saying that a material that due to some kind of reshaping will get a functionality that is useful. Oh, that was very sloppy, right? But it's something like that. So this is the advanced materials. So it's not just something you pick up finding in your garden, I say. This is an advanced material. So it's something that is shaped in some way or the other. It could be surfaces, it could be interiors, it could be interfaces, whatever. But there is some material aspect, some kind of processing aspect or shaping aspect to it. So it's about our ability to, let's say, master the material. Right?
Okay. We have another question, a couple of questions here. One is, do you consider standards or test guidelines?
Mm-hmm. Yes, we do. I mean, we think that is extremely important, and we believe there is a necessity for new kind of, let's say, green standards, if you like, or a kind of a green passport or whatever we like to do it, like a new ISO mark or something that actually certifies that the product has gone through a certain kind of set, clearly showing what is the green or what is the non-green footprint on making this product and recycling this product later. So I think it has to be a complete circle about this, and I don't know how that should be done. We don't know, so we would welcome people from the standardization area to join forces and bring this topic into the working groups and discuss about this, because I think we need to set up something very new, something novel that does not yet exist. But maybe I'm wrong, but that's my understanding of this.
Okay, we have a couple of more questions. It says one of the AMI goals is reducing environmental footprint, which is great. Is this cross-cutting across the WPs or a separate strand, and how are health and safety aspects addressed?
No, it's cross-cutting, so it goes through all these. So it's really a green band is kind of an or generic for everything, right? So it goes cross-cutting.
Thank you very much, Lars. And the last one I have is for clarification. So the AMI website states register my organization and not register myself as a person. So are there legal consequences for an organization, and why not the option to sign up as an individual or an expert from an institution? I mean, yeah.
Yeah, no, you can sign up as an expert from the institution, but you cannot sign up as an individual person, so to say. You should be connected to some kind of organization. In the first round, it was a little bit more strict. Then we say that the people that signed up could only be the one that could kind of represent or have the signing authority power, which is called extremely limiting. And this is not yet, this is not there now. So now it's open for people to, and that's why we also show if your organization is already registered, then you will see your organization there. And then you will not see who registered your organization, but you can ask us and then we can tell, because of data protection, we cannot give the name for that person without asking the person, so to say.
Okay.
So, but I think it is for everyone, but you need to, of course, to represent. And I think it's nothing strange, right? We all represent organizations if we are an employee of an organization. Yeah. So,
and perhaps the last one from me. To which extent do you think we can extract some lessons learned from the nanomaterials world? I mean, knowing that it was something that came up, I mean, that has been around there for ages, but for example, from the OECD point of view, we start looking at them like I think 16 years ago, and it was more about not trying to reinvent the wheel, but try to include them. And now we're trying to move into this advanced material. So I don't know if from your perspective there is some lessons learned, or if we have to really start from scratch as something completely new, or is this something that is not discussed?
I think there are plenty of lessons that I learned, so to say, and we don't need to reinvent it. I think we should go into this with, I mean, there has been a lot of things, if you talk about nanomaterials and its usability, etc., and a lot of standards about that. And in the beginning, it was all about, let's call risk and risk assessments. And then I think about maybe 16 years ago or 20 years ago, the focus was shifted a bit from risks to safety, because it's not the risk. Well, everything is risky. It's risky to take a walk in the street, but it's about safety. So, and I think this is maybe one of the biggest lessons in a way, that we should focus on safety aspects. How can we deploy these things in a safe and healthy way? Because it has to be good for everyone, the people that actually make it, dig it up, or whatever kind of material there is, or produce it, manufacture it, and also us that consume it or use it. And then in the end, how will it be the end of life of it? Because it should also be useful and not damaging the health or the planet. So I think it's really a circular kind of discussion, and I think there are a lot of things already happen in the, let's call it, nanomaterials world that I've been following since many years, that we should take advantage of all the discussions we have had and just put it into the system here, right?
Well, thank you so much, Lars. I don't see any more questions, but I really appreciate that you could sneak out from your other commitments to be with us today. Thank you so much.
Thank you. Take care.
Thank you. Bye. So next, if I can invite Denis from ISO TC229, our chair of ISO TC229, to present the work that they are doing on advanced materials. And Denis, the floor is yours. Nice background, jealous background. Please go ahead.
Thank you. Thank you, Mar. Thank you, everyone. I've been following these discussions. It's really quite interesting, actually, quite an eye-opener for me to follow this. My name is Denis Koltsov. I'm chair of ISO TC229. This is my third term of running this rather large committee. I don't do it alone, of course. We have about 35 active countries there. We just had a plenary meeting in London, which was very, very interesting in various ways. One of them was the discussion of advanced materials. And this talk, I decided to not bore you with slides. Standards can be extremely tiring, especially after lunchtime. So I am going to just talk like I am, and you can enjoy the background. What I will talk about is the actual history and what we can learn from nanomaterials and kind of import that into the advanced materials discussion. There are aspects such as definitions, health and safety, commercial aspects, and a few other sort of linking aspects, how this links to sustainability, circularity, and green agenda. So just going back quite a few years. I would say maybe year 2000, 2001, when Clinton administration really decided to push to put a lot of money into nanotechnology. There were many discussions on how to actually define it. Many proposals were sort of flying around, and different countries did it in a certain sort of different ways. And the original idea was to define something by its size. Now, size is an inherent aspect of a particle or a group of particles or a solid material. So you can actually measure it. Now, at nanoscale, we know that this is actually quite hard to measure. And we took about 10, 15 years to actually measure it. We are just about coming to a point where we can size particles quite well, down to about 10 nanometers, pretty precisely with all the number-based or mass-based particle size distributions. We've learned how hard it is to actually just in the pristine dispersion on the monodispersed particles to measure them and then report on what you find. So the original definition was therefore based on size. Now, there is nothing special about the nanoscale itself. So it is just basically 1 to 100. So I was chosen. There is no inherent risk or adversity or any problems at this sort of length scale or above it. The choice was pretty much political, because by the time that nanotechnology came to development, when Clinton administration decided to invest into it, other countries followed, of course. There was already microelectronics community, and they basically said, no, this is different. We're not part of that community, which ended up with a sort of micron size by definition. Of course, it didn't. It went all the way down to very small sizes later. And at the time, it was 1 to 100, basically just 2 orders of magnitude that people chose. Why is it 1 nanometer? Because we didn't want to deal with chemists. They have their own community. So it was something that sat between them. As we all know, nanotoxicology deals with particles that are quite often larger than 100 nanometers. This is where we come into the advanced materials in a moment. So the decision was to just put a stick in the sand saying 1 to 100 nanometers, and that's how we define it. So it is by an inherent property of the actual material. Now, teleporting 22 years from then onwards, now we're discussing the advanced materials. And the advanced materials became a really hot topic quite a few, maybe 2 to 3 years ago, when different countries and some other larger organizations decided, for whatever reasons, I'm not going to go into too much detail why they decided to do that. They decided to expand their scopes and to deal with advanced materials. I have to specify that, for example, E56 from ASTM, I considered this, but they didn't expand their scope. ISO TC229 didn't change the scope, but we already have sort of advanced functionality due to sizing. So we sort of can deal with advanced materials. And there were other committees that also looked at advanced materials. Also, the interesting push from maybe 5 or 6 years ago, when the funds for innovation were a little bit low, the decision was not to just fund nanomaterials or nanotechnology, as we've seen, for example, for European funding as well, but actually ask somebody to research into something useful. So in this case, advanced materials as a term became important because that material was actually doing something useful, some functionality, some performance. And this is where the definition now sits. And I know that OECD has sort of sandbox definition. ISO TC229 also take on this task of defining. I'm not going to go into the actual verbatim of the actual definition, but the crux of it is that this is a material that has a certain performance and an improved performance with respect to another normal or benchmark material. Now, this becomes extremely difficult because now we're moving away from nanomaterials, which is quite easy. Well, now it is easy to measure the size. And we're going to property or performance of that material. And we're characterizing a material by that trigger. So that means that, as an example, for example, we know that gold of nanoscale size, nanogold, is red in size, in color, right? So we can measure the size quite precisely in various ways. And then we say, okay, well, we don't want to deal with the size. We will use a property to define that. And it's red. Now, measuring that may be possible. It's very woolly because obviously it's not a distinct measure. It's not a very numerical thing you can evaluate, but it is possible. But then you can't just say any material that is red will have to be nanomaterial or advanced material, because that makes no sense. There are many other red materials that are not advanced or not nanomaterial. So this is a bit of a silly example, but a material that performs better than any other material before is an advanced material, of course. Is it nanomaterial? Not necessarily. So we're starting to explore the performance range that's completely orthogonal to our understanding of size. So size is not that important. However, in many discussions, when there are people who are extremely clever, they say advanced nanomaterials, which means that the Venn diagram intersects for very small fraction of those materials that are advanced, that perform well, and they're also nano. So that is actually not increasing the scope, that's actually making it much smaller. Now, the drive for advanced materials is clear. We have, for example, at the OECD, we have certain guidelines that are very, very well written. For example, ISO documents are also written, for example, for nanomaterials, but they could be used for materials of larger size. So, for example, take SEM document that may be used to characterize nanomaterials or nanostructures. That's fine. But SEM can be, if you zoom out, you can use it for larger sizes. The same sort of analogy goes for quite a few other tests and measurements. And in this case, why not use those methods to expand the scope of those documents? This is just a question that I would like to pose. So that in itself is a lot of saving. Now I'm going to go away from the actual definition because at the moment this is still an ongoing discussion, and in London 2 weeks ago we actually stumbled across a very difficult thing. For example, when you define something that is enabled, for example, by a material. So we have a term nano-enabled or nano-enhanced, or say graphene-enabled and graphene-enhanced. And then you say, well, actually, hold on. How do you define that? What is enhancement? Is it 1%, 2%? And why would we use 50% and not 51%? So these sort of discussions kept on going. I'm afraid I drank quite a lot of coffee at those meetings because, frankly speaking, it just kept on going. But at some point, this tumble dryer, the intellectual tumble dryer, will dry the laundry, and you will see it in public. But going into the private sector, I just have to really put a spanner in the works here. A lot of people who work with risk, safety, and all that stuff, we shouldn't overestimate the importance of it, because it's like a little triangle on top of a huge pyramid. That is a commercial activity. This is a requirement, no discussion about that. So materials, advanced materials, nanomaterials, they all have to be safe and used safely. But in the commercial sense, this presents only a small fraction of their activity. And the impact of those definitions that we just discussed, the advanced materials, goes into every aspect of that pyramid. So for example, advanced material, say graphene, for example. People use that as an advanced material. Now, this is actually quite an interesting thing. I had a project with a rather large client just recently, and their direct question was, what are the price points for certain types of graphene? And I said, well, that's a very difficult question to answer, because graphene being an advanced material, just like advanced chemicals in the past, cannot be sold at a certain price point. What I mean is that if there's a project that puts the same graphene in cement at large volume but low price, and in, say, biomedical applications, vaccines, for example, low volume but high price, the same graphene will cost different amount per gram. So there is no such thing as a uniform pricing. So therefore, it is actually quite an interesting development. And then you get the feeling for the fact that materials by themselves don't do anything. They would sit there. It is actual intellectual backing, the actual teamwork of the whole company that applies this material into an application that makes it more, well, makes it do anything. So in fact, the advancement of the material is dependent on that team, that know-how that comes with it. And I would disagree with some of the points that were made. European Union is not a material manufacturer. We are a service provider by many orders of magnitude. So other countries, Russia, China, many other countries, Brazil, they produce more materials than we do in various categories. But European economy is service-based. And for that reason, advanced materials links extremely well with the services. So there's basically a synergy between the supply of very good quality material that does something and the support of the services. So it's quite a complicated scenario. Just to give you a perspective, just give me well, I don't know, I don't think I want to ask that question, but in China, how many graphene producers do you think there are? And the answer is not 10, not 100, not 1,000, 16,000. They're registered by their own internal chamber of commerce. And how on earth does anybody know what sort of reproducers these are? They produce something. So this is the state of things. Of course, nobody knows how to check that, but that was their own report. So going back to our discussion, how do we make sure that the leadership of Europe, and this is actually the most important, how do we ensure that the leadership of Europe stays ahead of the others? And this is mainly marrying the materials with the services. And something interesting was said just now by the speaker before, that it has to be linking to standardization, to our concepts of circularity, green technology or green sort of certification. Side note on this, that in 1 or 2 years' time, this will be extremely important for the industry, because non-green industries will be penalized heavily. We know that. This is in the plan. You can read it online. So it is absolutely essential to have a definition, to have an understanding of what it means to produce something green and something not green. Nanomaterials have an inherent problem. Quite often you need to use quite a lot of resources, energy, water, etc., to produce a very small amount. So in this case, we need to be really careful how we marry the knowledge from nanomaterials with the advanced materials themselves. As I wanted to also mention, being a chair of ISO TC 229 gives me an opportunity to talk to a lot of people just recently we've been informed that ISO has signed the London Declaration. For those who don't know this, that means that ISO, as many other organizations such as IEC, IEC, they also need to consider climate change in their portfolio of standards. This means that we need to look at how our activity will impact the carbon footprint, etc., etc. There's lots of measures, sustainability globally. That also means that they probably will cancel all our travel, which will be a detriment to our community, but that's a different discussion. So the standards in the future will be linked to the sustainability and green technology levels. Please watch this space. A lot of things are changing really quickly. So advanced materials are high on the agenda. We have the sustainability question. I think that's probably about it. I'd like to just finish by saying thank you to your organizers for the invitation, and I'm very happy to answer questions if I can.
Thank you so much, Denis. Always very inspiring to hear you. And then I start like spinning all around. So this is really nice to have your discussion. I don't know if anyone will have some specific question to Denis. We will have time for a broader discussion at the end. But if you have any specific question that is really burning you that you wish to address to Denis, please raise your hand. Otherwise, just put it in the chat. And otherwise, we just wait for the end so we can have a discussion with the other panelists. Thank you so much, Denis, for keeping on the time and for being inspiring. Thank you.
Thank you for inviting.
Next presentation will be Harald Bosse from PTB, which is it's Kathrin. Sorry, Kathrin. Kathrin, that is going to be presenting the work that is happening at the OECD. So, Kathrin, I give you the floor. Do you want to share your slides, or you would prefer us to do it?
I can share it.
Excellent.
Can you see my slides?
Yes. Now, yeah, just presentation mode that you're on. Thank you.
A second.
Yeah.
So can you see it now in presentation mode?
Everything is perfect. Thank you.
Yeah. Thank you for the organizers of the meeting to invite me for a presentation here. I would like to give you some overview about the steering group of advanced materials of the OECD WPMN. Which includes reasons why the OECD is engaged in advanced materials, what the steering group achieved so far, and give you a short overview of what we are planning to do during the next months and year. Before going into the detail on the steering group of advanced materials, I would like just give you a short overview about the WPMN. WPMN was established in 2006 to address human and environmental risk assessment of nanomaterials, and the structure over these years, the structure of this working party changes several times. And the last structure before 2021 was to having 3 steering groups, one on testing and assessment, which continuously has been assessing the test guideline development and adapting needs, but also to provide further guidance on hazard and testing and assessment. There is also a steering group on exposure measurements and mitigation, which provides guidance on release and exposure testing and assessment, and a steering group on risk assessment and regulatory program, which continuously reviews the needs and important issues regarding the safety assessment of nanomaterials. And in 2021, 2 new steering groups were established, one on advanced materials, which I will present you in the next slides, and one on safer innovation approach for more sustainable nanomaterials and nano-enabled products. So what's the reason why WPMN is engaged in advanced materials since 1 year? Over the years, since 2006, it becomes more and more evident that the safety consideration of new materials should not be limited to an upper size limit of 100 nanometer, and that also for those materials, similar or additional challenges like those identified for nanomaterial can also be expected for these materials. For instance, that hazard and fate of these materials are not only triggered by the chemical composition alone, but also for some of these materials, it's expected that they pose or display additional complexity due to new or enhanced functionalities or a multi-component. And with this in mind, the question arises whether the current risk assessment can always be applied to advanced materials, which means not only risk assessment tools for chemicals, but also to those that have been established for nanomaterials in the last years. And with background of the discussions on sustainability, it becomes also clear that some of the materials may also pose challenges regarding sustainability through their life cycle, which also includes questions on recycling and waste handling. What did we achieve so far? As already indicated by Denis, the steering group established, we call it working description. So it's not a definition, it's a working description. And it describes what we do understand about advanced materials, and this description describes in which context WPMN is engaged with advanced materials. And since the expertise of the working party is nanomaterials, for us, the starting point for our engagement in advanced materials are nanomaterials or nanoscale materials, but our engagement will not be limited to it. And the description also acknowledged that what's considered as advanced materials today may not be true for the future, as for instance, the knowledge will increase about these materials, the technical process, but also if a material is at a certain time established in the regulation. So the key message about this description, what we understand about advanced materials are new and enhanced materials with new and enhanced properties or targeted and enhanced structural features with the objective to achieve specific or improved functional performance. This could be materials which are quite new, but also that comes from traditional materials that are modified to be more enhanced. But also this could be materials from innovative manufacturing processes, like for instance, 3D printing or electrospinning. And in the annex of this working description, there's also an overview provided about examples of advanced materials or criteria that helps to identify advanced materials in the view of the several delegations. So what makes advanced materials important also for OECD WPMN? As we heard already from Lars, these materials promises technical solution for the major challenges of our society, for instance, for the energy transition, for healthcare, but also for, let's say, construction that needs less resources, for more sustainable mobility or more sustainable agriculture, but also for the digitalization. And large investments have been undertaken to develop advanced materials and to bring them into application. And this has been done with the involvement of, for instance, of the European Commission, but also by European member states. And I'm quite sure that also in other regions like Asia or North America or Africa or South Africa and in Australia, similar initiatives are ongoing. And yeah, there are also several platforms by industry and academia to foster the development and the applications of advanced materials. So how does WPMN approach advanced materials? So we have three or four main tasks we are undertaken. For instance, we gather the information on research and activities on advanced materials within the different delegations of the Working Party. Then a main task will be to develop a strategic approach that supports the regulatory preparedness, but also safe and sustainable by design of advanced materials and their application. So this approach should help to identify if the regulations and assessment methods are fit for advanced materials, to identify if there are concerns about or knowledge gaps to address safety and sustainability of these materials and applications, and to develop recommendations and options for actions for decision maker. And yeah, with this, we also want to have to identify which of the advanced materials that are out there are relevant for the scope of the WPMN. And we want also to carry out case studies that on one hand helps us to learn about these cases, but also to verify and refine the strategic approach. In my next slides, I will come to the strategic approach, or the way we are going to reach this approach. As a basis for the development of the strategic approach, will we used the so-called early for ATMA system. This system was developed by Dutch and German national institutes, and first time tested at the WPMN at a workshop where we used so-called Maxime, which are 2D materials, as an example to learn more about this early for ATMA system. This early for ATMA system is understood as an early warning system that should help to identify safety and sustainability issues for advanced nanomaterials or advanced materials, and to also identify possible follow-up actions to inform decision makers. And it could also serve as a screening tool in risk governance approaches. And you can find this early for ATMA as a brochure at the website of the IRVM in the Netherlands. How does this system looks like? We have a two-tier approach. In the first tier, you have a scanning the field of advanced materials to select those which are of interest, and then have a first screening assessment regarding safety, sustainability, but also regulatory consideration. And depending if you have a green, yellow, or red flag, you will then go to a more deeper assessment of your materials. And this I will show you in the next slide. So if you go into tier 2, you have several topics, which are the application and market entry stage, safety assessment for human health and environment, but also the applicability of regulatory frameworks for the advanced material you're looking at, and sustainability. And for these topics, you have several questions. I will show you in the next slide a bit more details on these questions. Where you can score the questions, and depending on your outcomes, you then have the possibility to come up with several recommendations, and depending on which topic you identified issues or what kind of issue this is, this recommendation could be, for instance, to go in contact with certain institutions or stakeholders to gain more knowledge about the materials you're looking at, or to have more research to close knowledge gaps. But it could be also that you already could identify that certain guidances or test methods are needed, and you then should encourage, for instance, funding institutions to provide funding for this. I will give you now a short glimpse about these questions where you can score your results. There are questions on the market entry stage, for instance, about the uses and the how far these materials are spread over the market. There are questions on the safety assessment for human health and environment, where are questions, for instance, on classical hazard endpoints, but also if there are new or enhanced properties that may provide new hazard issues. There are questions also on fate and exposure. You have several questions on sustainability, which should cover the whole life cycle, for instance, about the diverse environmental footprints that are usually asked in a life cycle assessment, but also on recyclability or reuse. And you also have questions on the regulatory coverage, for instance, regarding the coverage of certain legislation, but also if assessments methods are available. And the importance here is that it's not needed to be able to answer all these questions, but also to identify if a question cannot be answered, that there is a knowledge gap that might be worth to be filled. So what will be the next steps? We will carry out a couple of case studies, and we have identified as interesting case studies the nanocarrier, which are used, for instance, for medicine, but also for thinkable applications for plant protection or cosmetics, 3D printing or graphene. And there are also some support from several EU projects like Harmless. We had a workshop already a couple of weeks ago, and also from the Asina project, it is proposed to have a closer look for case studies. And we will use the early for ATMA together with the case studies, like the Harmless project, to refine these case studies to meet the needs of the WPMN over the next months, but also then to identify information needs and possible concerns about the several case studies to derive recommendation for actions regarding safety and sustainability. And with this, for instance, when we had the Harmless project, we also took into account other approaches that are available to learn from these approaches, how they might provide input for our approach. And with this, I would like to finish my talk about the steering group of advanced materials and just give you some information about, we call it our sister steering group, which is a steering group on safer and sustainable innovation approach. We had a workshop or a webinar beginning of this month, and if you are interested what WPMN is planning for this topic, you can find a video recording about this webinar. And there are also several websites where you can learn about the chemicals program of the OECD and also on the nano safety program. And you can also sign up for a brochure and newsletter. With this, I would like to close my presentation.
Thank you so much, Kathrin. Let me see if there are some burning questions from you. Otherwise, we will wait until the end. I don't see any hands. No, and in the chat. So not yet, no questions yet, but just keep around so we can have some exchange at the end. Thank you so much. And now I will introduce again Harald Bosse. Thank you so much, Harald, for staying with us. And if you wish, you can share your screen now.
Yeah, thank you very much for this kind introduction.
So if I understand, Harald, you're also coming from standards.
I'm coming from a metrology institute, which is related to standardization. However, it's not identical to that.
Excellent.
But you will see throughout the presentation.
So PTV, go ahead. If you can just, yeah, that's perfect. Please go ahead.
Okay, great. Yeah, so welcome everybody. I was very much impressed by the presentations before from Lars, Denis, and also the one from Kathrin. And I also have to admit that we had recently organized a workshop where we also were very lucky to have presentations from Lars and Kathrin. So I try not to repeat what they have been delivering for the workshop of Nanoharmony and Nanomet today. Okay, so the topic is advanced materials from the perspective or approaches from metrology. Metrology, it's a word which is sometimes difficult to spell, different from meteorology, which is difficult for me to spell. Simply, metrology is the science of metrology is the science and application of measurements. So that's a very short definition. It's not restricted to ultra-high precision or very low uncertainty. Metrology is taking care of everything which is related to measurement and its application. That's an important information at the start. I would like to say a few words about Euromet, which is the Association of European Metrology Institutes, and the rather new approach to form networks for strategically important topics and themes in Europe, the so-called European metrology networks. Then I will come to a special one on advanced manufacturing, which includes one of three sections, and the one is on advanced materials. So in that sense, you might already guess that our approach here from the Metrology Institute, it's not just only on advanced materials. We see advanced materials as a very important part of the topic of advanced manufacturing. I come to that later. Then I will say a few words about the stakeholder dialogue and stakeholder consultations. And as the material initiative, which has been presented by Lars before, we are also in the process of setting up our strategic research agenda. So Euromet is the Association of National Metrology Institutes, which you can also, one of the 6 regional metrology organizations. So there are also twins, so to say, in Asia, in America, in Africa, and so on. And here's, well, the mission statement. I don't read through it. And we have a European metrology research program. I will come to that later, which helps us to achieve our goals with a co-financed research program on metrology topics. And in addition, metrology institutes take care that they regularly go into international comparison on key comparison topics in order to guarantee that there is a mutual recognition of calibration results, including calibration certificates, because as Anke Jesse has also pointed out, it is important with the technical regulations, OECD guidelines, and so on. However, also important at the very top of the pyramid of the calibration scheme, that also the national metrology institutes are in agreement with their measurement results. And you can have a look up in that publicly available key comparison database. There you see all of the different results of comparisons which have been performed. We organize our work along these different technical committees, which you see here, so links, electricity, and so on. And within these committees, we also concentrate our work to regularly organize these international comparisons in alignment with the other regional metrology organizations. So this is one topic. Also important to note is that we have activities in metrology for digitalization, with a cross-cutting topic. However, we don't have a specific technical committee on materials metrology, at least not in Euronet. That's in difference to the Asian committees who have such a dedicated materials metrology committee. Okay, so when we talk about advanced manufacturing as an example, you might easily see that it's not sufficient just to have a focus on lens metrology. As similar of importance, it's thermometry. If you go to laser-induced processes, then you have, of course, also to take care about photometry. If you go to fluid-based machining processes, where you melt something like in 3D edited processes, it's also important to know about flow metrology. So all of these things have to be also regarded on a cross-TC activity base. And this is done in the EMNs, the so-called European Metrology Networks, which are rather new networks since about 3 years or so, and one of them is on advanced manufacturing. And here you can read the other networks which Euronet has established so far. The main topic of these networks is to guarantee that there is a cross-TC interaction for specific stakeholder communities. And one of those is related to advanced manufacturing. Other ones we have here on quantum technology, for example, or the other topics. And these EMNs are then thought of finally serve as a single point of contact for information, including things like standardization and so on, to disseminate the knowledge which has been gained. I talked about this metrology research program, which is now running, and this is one of the partnerships which are part of the Horizon Europe research program of the European Union. And this is running in parallel to Horizon Europe with this budget ambition year. And every year there are calls on specific topics which are launched. And for next year, for example, we have one on fundamental science, which help metrology to progress. And the other topic is on industry. So next year there will be a possibility to propose topics to address research areas or open research questions where metrology is needed to support further progress of industrial developments. Also, each year there is a normative and regulation call. However, for all of these calls, it is important to note, and you can have a look up at this URL here. For all of them, it is important to remember that you need at least to have 3 partners from European National Metrology Institutes, which are member of that partnership. And the whole project has to be coordinated by one colleague from a European National Metrology Institute. That's a side condition. Okay, let me talk about advanced manufacturing. Why has this been chosen as a topic? The reason is that advanced manufacturing, along with advanced materials and the other topics which are listed here, are identified by the European Commission as so-called key enabling technologies. Also in their recent version, it's still advanced materials, advanced manufacturing together with the other things. And these help to fully exploit the potential. If you are able to fully exploit the potential of KETs, then this helps to create advanced and sustainable economies. Manufacturing is still at the backbone of the European economy. However, we have been losing ground, so they say in this high-level expert group, a vision paper here, I refer to this one. They say that one possibility or one way is to go to zero defect, zero delay, zero surprise, and zero waste production processes. If I, as a metrologist and member of PTB, as a metrology institute, have a look at that high-level paper here, and I search for metrology or I search for the term measurement, there is no mentioning at all. However, if I look for quality, then this is addressed somehow. So what we as metrology institutes also need to act as a translator and to raise the level of awareness of people in the manufacturing industry that they know about the potential of metrology to support their targets. In this metrology network, which has been established about 1 year ago, we have national metrology institutes, also support from research institutes, university. We have a stakeholder council, which are depicted here, the organizations which are represented by the stakeholder council members. And all of this EMN is now active, and you see that we have partnering organizations here. This is the ETP Menu Future, where I have referred to that high-level expert group Vision 2030 paper before. We have 3 different sections, and one is on advanced materials, one on smart manufacturing systems, and then manufactured components and products. And we try to take into account the whole manufacturing chain, from design up to full use, and then recycling, second use, and so on. And the target is to develop a strategic research agenda by the end of this year. I will come to that later. Let's have a look at the advanced material section, which we have here. And this is a copy from our website, where you can see we have different experts here from different metrology institutes in Europe. And I just allowed to take out George Favre, who some of you might know, Dan Hororaba from BAM, Alex Evans, who is an expert in additive manufacturing, also from BAM, and of course also from NPL. We have Fernando Castro here, is also currently quite active in ISO, and also he is the current convener of the BAMAS committee. We have tried or dared to make something like a working definition of advanced manufacturing, which is quite technology open. However, it's a little bit more than just explaining what advanced means. We have made a study of TCL to try to compare the national requirements with the capabilities in dimensional metrology for European metrology institutes, which is depicted here. And we identified the European industrial sectors with respect to their potential to really benefit from progress in metrology. And here we came up with a list of 13 different key industry sectors, which we would like to focus on. And there's an open access publication you can read if you are interested to get more information. This is the schedule of our first meeting, which we had in October last year, with presentations from our colleagues who are somehow representing these key industry sectors. From our partnering organization, you also see NanoFabNet and USPIN here. And then we had another meeting in July this year, one open consultation, which was jointly organized by Euramet and our metrology network. And the topic was metrology for semiconductor technologies. And here you can see, and here it is also written down for better readability. Separately, contributions from larger companies in Europe who are progressing manufacturing of the semiconductor components. And we also had Yves Gigas, the head of the program of the Key Digital Technology Partnership, because it's important for us as the partnership on metrology research to cooperate with others who are under the umbrella of Horizon Europe. And these are some details information. I don't go through that. This is just an information about different projects, research programs, which are funded or have been funded from the predecessor of the European Partnership that was called MPIR. We are, as metrology institutes, also active in Excel or now KDT programs, and we have been also contributing to Horizon 2020 and will continue also to contribute to Horizon Europe projects. And if we are allowed, we then also publish results from our cooperation. Sometimes, however, we have cooperation projects, direct one between industry and NMIs, and there we are sometimes not allowed to publish them. Okay, let me come to the last or second last slide. There is, just a month ago, we had a meeting at NPL on the focus topic was on advanced materials, and here you can see we had presentations from Lars Montelius and from Kathrin Schwirn, so I don't want to go in that. In addition, we had, because we were in the UK, we had presentations from 2 industrial companies from the UK and also a presentation from the APMP, that's the Asian Committee on Metrology, where there is a technical committee on materials metrology. And we then had in the afternoon also an open workshop where we have discussed the first version of our draft strategic research agenda. And this is a little bit somehow explaining the process of stakeholder engagement, trying to identify and define stakeholder needs, then to respond to the needs with a strategic research agenda, then to go together with stakeholders into collaborative and specialized research projects, and then further build and intensify the relationship with stakeholders in the important topic of advanced manufacturing. Where are we now? We are concentrating on our key industry sectors. I gave you an explanation of one of our consultations focusing on nano and microelectronics, another one on advanced materials. We see these cross-cutting topics where you see also advanced materials. So it's a key industry sector and an important cross-cutting topic for our work in advanced manufacturing. The timeline is that somehow in alignment with the advanced material initiative from Lars, we also try to have something published by the end of this year. So the plan is that on the ENM website you will see the listed content of our preliminary SRA by the end of this year, and then we have a requirement to produce a final polished document by May 24. Okay, and with this, I would like to thank you for your attention, of course, the funding and the colleagues in the ENM, and I'm open for your questions. Thank you very much.
Thank you so much, Harald. Thank you for, so with Harald, we conclude the series of presentation. Perhaps I can ask Kathrin and Denis to turn on their cameras, please. And now I would like to invite all of our participants to ask if you have any questions that you think that pertain to all of these speakers. If you have something that is really burning for one of them, please go ahead. Perhaps just to break the ice, one of the things that I would like to ask you is, I mean, we are all somehow, for different reasons, for different triggers, involved now on advanced materials. And my question will be, to which extent do you think that we can help one another based on the experience from your own organizations? How we could build some common grounds or identify some synergies in working together. So I'm referring to metrology, I'm referring to ISO, and I'm referring to OECD. So anyone that wishes just to jump into the brainstorming, please go ahead.
Yeah, if I may start, and then the colleagues may comment on that. Just to tell you a little bit from the German perspective. So the PTB is a metrology institute, and the BAM is a materials testing and research institute, materials testing. They both have been invited some 12 years ago, I think. Kathrin, you can say yes or no, but I think it's 12 years ago by the German Ministry for Environment to join a working group which already existed there, which had a clear focus on risk analysis on nanomaterials. And then they missed somehow the expertise of metrology institutes and material characterization. And so we joined that committee there. And since 12 years now, we have been cooperating and developing a joint research agenda for nanomaterials with a special focus on risk analysis. And this now has been extended, I think, 3 years ago or so to a wider topic. So the topic advanced materials is now in the focus, but we will continue to have that working group where we have the governmental agencies on environmental protection, where Kathrin is representing, and also the other ones. So that's a good idea. And I think with this cooperations within OECD, but also this new network where we have George Farber from LME as our vice chairs for the advanced material topics, at least what we have achieved, I think, or what is on at least a clear target from my point of view, is that we have used all channels in order to mutually inform us what's going on. Of course, not too early, because maybe some things have to be discussed nationally at first, because before they then can be brought into the international discussion. But I think that's important to keep the major players like the governmental institutes, the metrology institutes, the standardization institutes like ISO TC 229, the committee, and the OECD working party on manufactured nanomaterials, which now also has expanded its work, as Kathrin has said, on advanced material to keep us all in the loop. Okay, that's my preliminary statement. Thank you.
Thank you, Harald. Kathrin?
Yeah, maybe from the perspective of the steering group of advanced materials, I think the collaboration with the metrological institutes, but also with ISO, is very important. On one hand, I mean, we have identified materials where we think we have to look at, but maybe the other communities have more understanding about the materials, what this materials is and where it's used for. But also when it comes...
Comment.
Sorry, there's someone in the background who is unmuted. When it comes to the point where we see we need certain methods to be able to characterize these materials or to analyze these materials regarding hazard, then the other communities may have already knowledge about the methods we need and or could help to then preparing test guidelines or guidance, or have already done validations where we can build on. And on the other hand, we can help them to understand what our needs are. Yeah.
Thank you, Kathrin. Denis, do you want to add something?
Just two things, actually. The recent trend in obviously looking at materials for their performance or what they do, not what they are, but what they do. That actually poses quite a big philosophical challenge to metrologists themselves. It is actually quite simple to characterize what you have. Well, relatively simple. Nanomaterials are not easy at all, but it is doable. While performance is an extremely difficult one to evaluate. Strategically, at TC229, we actually created a new working group that looks at applications and products performance. And this is actually quite an important change in standards writing. Most standards that we have seen in the past, and many other committees do that, you basically standardize what you put in, so not what it does. Performance standards are quite a difficult animal to handle, because you have to realize that it doesn't always matter what you put in, it's what you get out that's the most important. And it's not always correlated. So the same graphene would perform very well in one application, but would trail completely behind other materials and others. So it's not anymore enough to know the size or the thickness of graphene layer. It is actually important to see what it does. And indeed, the same graphene could actually be absolutely awful in some applications. So developing standards, or maybe we call them umbrella standards, because they would rely on non-nano standards that are developed by other technical committees, but we would need to sort of assemble them into a sort of comprehensive compilation to say, this is how you do how you verify that your plastic or your rubber is better in doing what it should do when you put graphene in there. This is a very, very narrow example, right? So advanced material in a sense depends on that. It depends on that measurement of performance. Without it, it's pointless to even mention advanced material. It's just a material. And of course, we understand that advanced materials are not necessarily new, and new materials are not necessarily advanced. So linking that with toxicology or risk measurement isn't always appropriate, because not everything new is risky, and not everything that's risky is advanced, or vice versa. So we need to really understand this. But first of all, we really are throwing a challenge to metrology and standardization committees. We need more understanding of how to prove that something is advanced. And this is actually not coming from me. It's actually coming from the companies that are trying to sell, say, tennis racket with carbon nanotubes. It's lighter, stronger, maybe cheaper, maybe even more ecological, maybe more circular. But they need to show that. And they need to show that to not only very informed public, who are the procurement officers or whatever, who know exactly what these materials are, but actually normal consumers. And this is actually a really big challenge. So this is one, and then the definition of advanced materials. We're expanding the scope of our activities, and I know for the OECD, for ISO, this may actually present some opportunities, but it's also a risk. Are we opening up the discussions we had in 2005? Where NGOs openly stood up and said, you put nanomaterials in there, we'll boycott your product. And I was there. This was happening then. Are we opening up this discussion again? This is a risk that if we don't handle this discussion properly, there will be a backlash. And we've spoiled it already in Europe for nanomaterials. A lot of companies literally left the area. So we need to be very careful in opening this up again for advanced materials. So the link between the novelty and the risk needs to be very carefully considered. I personally totally believe that everything new has to be evaluated for any risks that may pose. But just calling something advanced does not put it in the category of asbestos. So please don't link the two.
Yeah, no, and I think that's something that I mean you have mentioned in several occasions, and I think that's something that we agree with you. I mean, we don't want to advance doesn't mean risk. It's not an equal equation, and it's something that we want to get out of it. And I think the current context, I mean, and linking a little bit with the experience that we have with nanomaterials. I mean, before we were, I mean, and trying to look about why we are now moving into advanced materials, and it's really about how we have moved from safety assessment for environmental safety, and now we have to add this component about we're looking at sustainability, we're looking that it's recyclable, we're looking that it's less energy consuming, et cetera, et cetera. So how we retrieve these experiences, but from the positive in moving forward, where you don't lose sight of the things that we need to assess But it's come back. I mean, and I know the concept of advanced materials. It's an electric concept, but we have a question in the chat, which is defining advanced materials the first step on the road to regulate them? So I think all of you have mentioned that at some point you have done. I mean, OECD, we have a working description. Harald mentioned a working definition. I know the ISO has been also trying to put some boundaries on it. So the question that is there is, do we need to do that as a first step?
And I try to answer that as holistically as possible. First of all, there is quite a big difference between the OECD and the ISO. You guys are quite serious about regulations, and the regulators, the national regulators, are actually listening to what you guys are writing. This means that if you make a hard definition of advanced materials, this will be actually counterproductive for the industry, because that will lead to hard regulation in this particular field. So the definition is inherently supposed to be quite woolly, and I support that. Germans support that. Many other countries are supporting that. ISO, we don't regulate. We are not compelling anybody to use ISO standards. We're not elected to do that. We try to provide correct definitions for what they are, and people have to really know the difference between those two. So ISO is actually free, relatively free to make this definition as it's supposed to be defined by the community that we work with. The OECD is one of our very good contributors. The structure of our definition is quite simple. It's something that performs better than whatever it is. It's an advanced performance. But then there are about 8 notes, and in the notes we specify what we think that these advanced materials are. Technically speaking, notes are not mandatory, so they're kind of optional, informative. So we're sort of playing cleverly on the actual terminology, or the way you do terminology. In many ways, the actual definition is at the moment intentionally woolly. Regulation, well, we will see. I don't know if we need that. There is also, somebody mentioned in the previous talks that blockchains, I know it is really fashionable, but just remember that blockchain is decentralization. That means it is the opposite of centralized regulation. So bringing the two together in the same talk is not clever, but we will see. We will see where it goes.
Thank you. But at the end, you do have to put some boundaries. I mean, ISO, you did put some boundaries, and I think it was part of the question. And when we have this discussion, we always have someone that, but if you're not defining this, how can you even start thinking about it?
We tried to be as specific as we could with the group of people that we had. Double the group will make the definition a little bit different again.
Yeah. Kathrin?
Yeah, also from OECD side, it's not the aim to have a regulatory definition. It's rather to have a common understanding what we understand of advanced materials, and on which kind of materials we would look like. And also from, let's say, regional level or a national level, I doubt that a term like, or a definition for a term like advanced materials is helpful for regulation, as it's quite too broad. It's rather that one has to make sure that hazards or risk that comes with certain kinds of these materials are able to, or will be covered in the regulation properly.
Okay. Harald, do you want to add anything, or?
Well, I just can support Kathrin's point of view, and this is also a little bit similar to our approach for our working definition of advanced manufacturing. Basically, I also think that you cannot base regulation just on a however well-defined the term advanced material will be or advanced manufacturing. What has been our, let's say, main point of view is in particular what you call advanced today may be standard technology tomorrow. So that has always been a trend, and this should not be forbidden also by any sort of or kind of definition. We should, and this is in agreement also with Denis' point of view. So ISO definitions in particular, but also others should not limit further progress of technology, which is in the end then hopefully beneficial for all of us, as has also been pointed out on the example of advanced material by Lars in the beginning. So that's the reason why we set for the advanced manufacturing working definition. Okay, we start on, and that was very high level definition by CERT, the International Academy for Production Technology. They had a definition for manufacturing, and now we were sitting together with colleagues having experience in other ISO work in other ISO committees, and then saying, okay, let's propose this working definition of advanced materials. Let's manufacturing. Let's keep it technology open. And now we have submitted that to CIRP, and it's now under discussion if they will follow our proposal.
Thank you so much. And you have all mentioned, I mean, we all come from nanomaterials field, and we are now moving into advanced materials. So my question to you, from your own perspective, to which extent we can use advanced nanomaterials, the experience that we had on advanced materials, and already Denis mentioned what we shouldn't be doing because the dangers of going into that path, but perhaps what are the things that we could actually apply, and what are from your own experience in nanomaterials, what could we use for moving into advanced materials? Who's dance? Go ahead, Denis.
No, Kathrin, go ahead.
Thank you. My first thoughts are that what we learned from nanomaterials is that we may have to look more on just the chemical composition, that there are more things like here surface or morphology, and these are aspects that are also relevant for some kinds of advanced materials. Let's say for particulate materials, or even if they are larger than 100 nanometer, but I can't say for the moment what would be an upper size limit. This is, one point we could learn from it. But of course, there could be others.
May I just a quick point to return on to the distinction between the size and the performance. The early discussions of nanomaterials, people got really upset and didn't really understand why companies used nanomaterials. They just seemed to normal public as just something smaller, finer, or whatever. The actual benefits were not translated very well to normal public. In other countries like Thailand or Malaysia, nano meant augmented performance, in which case they would buy toothpaste or shoe shine that relied on nano and would pay 30% more. We didn't do that in our society. For us, the main problem was that academics from their ivory tower kept on just lecturing everybody how amazing nano is, without actually saying, well, this toothpaste will actually do a better job than the other one. Here with advanced materials, by definition, it's already doing something better. Otherwise, we wouldn't use that term. So we're sort of out of this. But the toolkit that we developed in terms of actually characterizing it, developing material, the life cycle, looking at the end of life, all of those things, they are extremely important, and some of them, they're not really limited to 1 to 100. They would be working for micron size particles, etc. So we've learned a lot, and we've also learned what not to do. So the last thing we want is to lecture to the public how great graphene is without actually backing it up for particular applications, saying you don't need to know it, but it's safe and it does things better. Here it is. That would be a different reaction to we put this in our product. Isn't it wonderful? And we've seen many startups going this way and then disappearing.
Thank you, Denis. I don't know, Harald, if you want to add anything.
Yeah, I have no general advice or experience. I just can say I have been at the first ISO TC 229 meeting, which was the first one was headed by Peter Hettel, so that was a colleague whom you definitely know, Denis. And so based on that, I just want to say, yeah, to some degree, of course, the whole discussion is also a little bit driven by the larger research programs. So in 2005, when ISO TC 229 was founded, nanotechnology was still high on the agenda of all of the national research strategies, and in particular also the European research program. So this has changed a little bit, and now it's more advanced materials. I think that that's worldwide now a little bit stronger on the agenda, and this drives, of course, the interest also in the topic of advanced materials. And we must be sure not to promise too much what we can do, so to say. We must be sure that things are still safe when they will be put on the market. That's the point. And there's also a little bit different approach in the different regions of the world to new things, so to say. I once visited Taiwan, and our colleagues in the Taiwanese Metrology Institute, they are also responsible for testing the performance of products which are produced in Taiwan under the so-called nano mark label there. So in Asia, these things are seen generally by the public more positively than maybe in Europe, where we see public is used to seeing new things more related also than to the possible hazards and risk related to that. That's also a little bit different, and yeah, this is just should somehow make us sensible that if we do something in Europe that might be interpreted differently also in other parts of the world, which makes it even more difficult to get an international accepted definitions in the end, or fully accepted international cooperations as well. It's just a remark.
Thank you, Harald. And I think, Alberto, you want to take the floor, please go ahead. You're welcome to put your camera.
Yeah, thank you very much. I have a comment on graphene, because Denis has talked about graphene as an example. I'm from the graphene flagship, actually, and we are looking there on the safety aspects. But my comment is more on the performances, because the advanced material, and graphene can be considered one advanced material, they should perform better. But I think it is important also to look at the different application, because if you can measure, for example, the conductivity or the charges, and then you compare with other material, is something that you can measure directly. But if you go in the biomedical field, for example, comparative studies are lacking. So it would be very difficult in this case for an advanced material to give an idea if it's performing better. It can perform differently, or it can have additional properties, but yeah, you need to have somehow a way to measure the performances that are much easier in some fields than other.
Very good point. But you know, there are there's a distinction between the nano-enabled and nano-enhanced, or graphene-enabled and graphene-enhanced. So what you're saying is that I completely agree with that. That if there is no property that we know without graphene, and once you put the graphene in there, you have a new measurand or new endpoint or something new, some new performance that didn't exist before. It's very difficult to compare, and this is definitely true. But this has always been like that for nano-enabled and nano-enhanced materials. We struggled with it actually at ISO to define it properly. This time around in London, some of the old people, Harald will probably know Mark G from NPL. We were sitting there and discussing this advanced material issue, and this nano-enabled and nano-enhanced term came up. And Mark just said, well, actually, we didn't think that about this, because you don't know by how much it should be enhancing, or what should be considered enabling, because you said it correctly. It could be a completely new aspect that we didn't have 10 years ago, like circularity or sustainability. Maybe the new tennis racket that you put graphene or
Yeah.
in there becomes something else, but we didn't know how to measure before.
Yeah.
Yeah.
Thank you.
Thank you, Denis. And I think we have come to the end of our short discussion. But before I close, and I close this part, and I give the floor to Elisabeth, I just want to ask if any of you, Harald, Kathrin, Denis, if there's anything else that you wish to add, other than what you have already said. But if just to give you an opportunity, if there's any message that you want to give.
No, nothing to add.
Excellent.
I guess we said what we wanted to say, but thank you for organizing this discussion. It's really helpful.
No, thank you so much for joining. I know that you are all very busy, and sometimes with multiple workshops and meetings at the same time. So thank you so much for staying here. So perhaps now, Elisabeth, I can give you the floor. And I think, yeah, you're there. Thank you.
Thank you, Mar. So it's me again, giving the last words here and keeping you, well, at least if you're based in Europe, from your afternoon coffee, probably. So everything that is left to say from my side is thank you again to everyone who contributed to the workshop yesterday and today, to all our speakers for today, and also the ones who did the organization in the background. So today, what we heard about was, again, some test guideline developments, or also the scientific work that leads to the test guideline developments. So some examples giving from RISC-GON, having done a huge work on test methods, and also having a look into the bioaccumulation and the tiered approach. And again, seeing that we need to be in contact with scientists and to see what new methods and approaches come up, and to take them up wherever possible into regulatory relevant test methods. Yeah, and then in the morning we also had the talk from Anke, giving like the broader view on why we are doing this, where we're coming from, and probably also where we're heading. So, and in the afternoon we had a look into the future and into advanced materials and what is coming up and the challenges, what we see also in the future. So next slide, please. So to sum it all up from the two days, I tried to put some key messages here. I hope you more or less agree. So we see what are the current achievements and advancements in OECD test guideline developments for nanomaterials. We had a discussion on the engagement of different stakeholders at the OECD process, and also at finding new ideas for test guideline developments and looking at the phase where we use the test guidelines developed. And I think we can all agree that we need an effective and long-term engagement of the different stakeholders, and also keeping in view the needs of the CROs who are testing according to test guidelines, and then to see what is coming up from science and to combine that with our regulatory needs. And the afternoon today we spent on the lessons learned from test guideline developments of nanomaterials into what is probably needed for advanced materials, what other issues are upcoming, and having a look into the future on that one. So next slide, please. So what we're aiming for with the NanoHarmony legacy is to have a long-term and continuous effort into OECD test guideline amendments and developments for not only for nanomaterials, but probably for a broader field of materials and advanced materials, and to giving an input there and to supporting that, and to also support for future times a platform where we can go on with a stakeholder exchange, as we have, for example, here on a broader range, and also to have a platform for priority setting towards harmonization of test guidelines, what is needed, and to have like structured discussion in the future times. So one step is this workshop today, but looking into the future, there are upcoming other events I wanted to draw your attention to, and what we want to use to structure our thoughts and to gather inputs on the way forward. So in January, there will be the NMPP 13 final conference, where there will be a round table on harmonization and standardization. NanoHarmony is planning a meeting in Brussels in April next year to also address more the political side of people. And then going further towards the summer, there will be in June the Nano Dialogue final conference organized by Anke Jesse in Berlin. And last but not least, we will have our final NanoHarmony meeting in September 2023, where we also finish our NanoHarmony project by then. So that's from my side. I hope you all enjoyed the workshop. Thank you to all of you for your input, for the discussion. To finish this meeting, I think it would be very nice if we can all switch on our camera for once, so we can see each other for once at the end of this workshop, even if we don't meet in person, just to say hello to everyone.